Have you ever heard of a hybrid? Yes, I know. The first thing that may come to your mind is something like a centaur, half horse, half human. Although that is the things of fairy tales, there are actual hybrids that are among us today and that have walked thousands of years ago. For example, the first hybrid 4,500 years ago in ancient Mesopotamia was called the Kunga. It was the result of breeding a wild ass with a domesticated donkey, which does differ from the donkeys of today. Why did ancient Mesopotamians do this? Well, according to Harrods.com, the donkey, being the workhorse essentially, the strongest domesticated breed that they had at the time, had its strengths. Its strength was its strength. Then the wild ass, which was faster than a domesticated horse, was valued. However, it was not as strong as the domesticated donkey, and they were hard to catch since they were so fast. So either one was captured or a female domesticated donkey was placed to where it could be bred with a wild ass. The reason Harrods.com knows that who was the father, who was that, is because the mitochondria that was found off the DNA of a sample matched that of a domesticated donkey, whereas the Y chromosome in the DNA matched more the Syrian wild ass of that time. Now that is interesting. So now that we've talked about more ancient hybrids, what are the hybrids today? So the Syrian wild ass and the domesticated donkey hybrid was called the Kunga. The Kunga is super similar to our modern day mules. Similar reason too. Strength from the donkey, speed from the horse. And in that, most of the time, you weed out the stubbornness of the donkey, which farmers prefer. According to Frontier.com though, hybrids such as said mule and bananas aren't fertile. Prior to the speech, I didn't know that the common day banana is a hybrid. It does not have seeds, however, it is a fruit, which I found so very interesting, and I wanted to share that with y'all. Two banana plants are not able to asexually or sexually reproduce. I mean, given it's a plant, it has to be genetically engineered, bioengineering. So what is hybridizing on a genetic scale? When you take the DNA from the mother and the father. For example, we're going to use a lion and a tiger. Traditionally, in scientific way, the DNA splits into single strands of DNA, and each strand goes with the corresponding other single strand from the other parent's DNA, and it retwists in the helix style example. So it twists with each other, forming two new combined double-stranded helixes. Now, this may sound super confusing. Essentially, there's adenine, thymine, cyanine, and guanine. So C goes to G, A goes to T. Sounds a lot like biology, but I promise it's gonna pay off. With each pairing, you have what's called an allele. An allele is the thing that determines the genetics, what genes you get, what traits you exhibit, whether that is phenotypic or genotypic, whether it's physically shown or carried and not physically shown. This determines what factors you get from a parent, which can be found through genetic research. For example, reverting to the Kunga, this is how they knew which was male and which was female. So, with all this being said, we have hybrids from 4,500 years ago, the Kunga, and today, ligers, bananas, mules, and a major problem we've been having in the Everglades in Florida, the bait eaters. What is a bait eater, Lucas? Well, bait eater is the hybridizing of an African rock python, a reticulated python, Burmese python, or some cases debating a ball python. Well, these are just a bunch of species of pythons. Yes, but bred together, they combine into the Florida bait eater, which is wreaking havoc because it is a top tier predator with no natural predators. Hybridizing animals can either work in our favor, against us, or turn into something we can't entirely control. Needless to say, it is super interesting, and I'm so glad I chose this as my topic. Thank you.